So this hardware review is something I'm very excited about. This is a single board computer. It's called a Radxa, I'm probably pronouncing that wrong, but Radxa, which we'll have a look at the specs and everything in a minute. It's a single board computer. It has an on-board Raspberry Pi 2040, which is old. Let's do a tour of the chips. So there's your RP 2040 there. It's got NVM there. Hasn't got onboard Wi-Fi or anything like that. So you can but you can get a little Wi-Fi card if you want, or a Bluetooth card. Compared to the Latte Panda, which I've looked at, it's got less on board, but I quite like that. It's got two USB 3s, two USB 2s, powered by USB-C there, so you can get a power supply. It has to be like a 3 amp 5-volt power supply from Pi Hut for about £11. Two HDMI's here and here, audio jack, which is novel. We turn that over. Wink. It's got the NVM SSD there. I want to say SSDC. SSD there. So this one's an 8 gig RAM, which hides underneath the fan here, and it's got a Celeron J4125 processor, which I don't think is being made anymore. So even though this is a new board, they've specified a processor which is, I assume there's just lots of stocks. But anyway, the 4 gig version of this board comes in at £40. So I don't know, what's that, $52? The 8 gig, which this is, comes in at £56, so $70 odd. It's remarkably cheap. It's cheaper than a Raspberry Pi. Doesn't come with the clock, doesn't need the real-time clock battery, but it improves boot up speed. So for the pennies that costs, it's well worth having that. You've got a boot select button there, which you have to press. I've found you have to press when you boot it up and release, and then that will allow you to put firmware onto the Raspberry Pi. It comes up as an extra hard drive. Talks to the Raspberry Pi through the UART, but it's quite nice because it's all on board, so you don't have to worry about connections or anything like that. It's got a button there, which is the reset button. And it's got a button here, which I don't know what does. Doesn't appear to do very much. Perhaps it's just a special button. Let's have a look. What does it say, actually? Headphone jack. So we're down by the power supply. eMMC recovery button. Oh, that's the other thing. It can come. You can get one which has 32 gig of onboard eMCC. I didn't bother with that just because I quite like having all the components, but it is an option. Also, it's out of stock. So if we look at stock now, let's have a quick look. Oh, it's got gigabyte Ethernet on board as well, which makes it fantastically useful. So if we have a quick look at screen 2, doink. So here's where I was cribbing off all the parts. This is rest.com. It has documentation. It's okay. I would say that's as far as I would go. It's not fantastic, but it's enough to get you around. You buy not from Radxa themselves. They always go through a distributor. I've used this one. I think Derek has used this one too. So here's the pricing. And these are the two that are in stock. Comes without the fan. The fan is about £8, and the coolant fan and heatsink, that's about £8. You can see there. What we got there? Yeah, there's the fan, which I think is a good deal. Runs very cool. So my Latte Panda the CPU was running at about 65 degrees. This runs at 50. It's a very well cooled and performant little beastie. And what we'll do in a bit is I'll plug it all in, we'll boot it up, and I'll show you it running LabVIEW, and LabVIEW, and we'll get access to the Pi header and show it doing things. So I've moved it all over so we can plug in my breadboard, and it's also, I've just used a cobbler sort of, I think it's called a cobbler, which is this thing here. It's just a ribbon cable to a pin out that I can plug things in. It's not quite pin compatible. What Radxa have done, have tried to make the header Raspberry Pi compatible, not Pico, because I think they have accessories they'd like to plug in. So you can buy hats essentially that you can plug in. So it's compatibility with hats rather than the Pico compatibility. So you have to do a little bit of jiggery pokery with the pins and things. But there's some internal wiring that you need to be, but all the schematics are available, which is also very good. It's always nice to have all the schematics so you can see all the internal wiring, which is very handy indeed. So it's all plugged in, but let's have a look at the operating system and various other bits and bobs. So I'm using no machine, so bear that in mind when I'm doing, when you're viewing performance. It's also got the overhead, because it's a tiny little single board computer. It's got the overhead of being remoted into. No machine's pretty efficient, but you can see there's an ongoing thing. And this is Debian, so I've been using lots of different distros just to see which one I like best. So Debian was just one I'm testing. I quite like it actually. It's quite nice. LabVIEW sits quite nicely. So let's just load LabVIEW, and you can get an idea of the performance. So we load LabVIEW here. Boop. That's quite nice and quick, nice and snappy, I think. We'll load our hands-on. The hands-on project is relatively big. I mean, it's got stuff going on. So you can see there's lots of bits and bobs in the project. You can see again, quite snappy. You know, this is not a supercomputer, but that's fine. You know, you can move things around and it kind of works. He says that. There you go. Kind of works. So, you know, you wouldn't want it as your daily programming driver, but my idea is that you build a virtual machine with the same operating system and specs onto a decent computer. You write your software, so you would only need LabVIEW on this if you're really debugging at a system level. You know, you can use it to program on, and I also think for training it's absolutely fine. You know, so if we go new VI here, you can see drop a. I'm not going to do a for loop because it always gives me problems. Whoosh. But you see it, that's fine. Looks nice, you know. Stick a waveform graph. Oh, chart. Let's have a chart. It's all, you know, a tiny bit of screen lag there. We can see it just catches up. It's not horrendous, you know. It's quite manageable. I think I've certainly programmed on very much worse systems than this. So yeah, that looks very nice. So let's close all that down. Boop, boop, boop. You can build executables as normal. You just have to start from scratch. For each system, I would just copy it over, and that works fine too. Executables work fine. So, you know, you can use this as a basis for a nice little embedded system, and very, very reasonably priced. And it's even got some onboard hardware. So, you know, I think it's fantastic. I'm shocked how fantastic it is. Boot up time is quite snappy. I mean, it's slightly faster than the Raspberry Pi, I think. I think that's probably because it's straight SSDC. SSD. I don't know. It just seems a bit snappier. Because it should be a bit slower than the Latte Panda, not the Raspberry Pi. It should be a bit slower than the Latte Panda because it's not the N100, which is the latest and greatest chip. But if we reboot this now, we don't want to log out. sorry, new distro. Log out, quit. Right, shut down. If we shut down, see the light will go out. Well, the fan will stop. Yeah, so see the fan stopped here now, and you can see no machines. There's nothing there. So boot up time. Let me just put my stopwatch on and press the start button. So this is booting up. This is a very poor measurement really, because it's just when no machine wakes up and says I have an operating system. So let's have a look. So that's got to kick off as well. Always seems an age when you're watching it. And you'll probably get down because there's probably menus and things like that. There we go. So that was 30 odd seconds to boot up. So that's pretty good. You know, I think if you actually optimized it so it wasn't going through sort of startup menus and things like that, then which I think the booting, you know, is an optional thing. You can get that down to sort of 15-20 seconds, quite nice, and that's pretty snappy. You know, that's you know, if you compare it with sort of instruments out in the wide world like an oscilloscope or something, they boot up, they take easily that amount of time. You know, so you can build quite a nice, fast embedded system here that works very nice indeed. So next I'll go and plug in some wires, and I'll just show you the Raspberry Pi doing its thing, or the Pico doing its thing. So bear with. So we're a few days down the line now, and I've reinstalled Debian, and I've reinstalled a new version of LabVIEW, and I've done a quick boot up test because I turned the boot up menu options off, and Debian boots up in about 20 seconds. It then goes and wakes up in no machine another sort of between 7 and 8 seconds later. But the actual boot up time when it's alive is about 22 seconds. It's not bad at all. So that's cool. So this is where we are now. So I've loaded LabVIEW 2023 just because it works a little bit nicer on Linux than 2024. It will be fixed apparently in Q3. I've connected a T-cobbler, which just connects the standard Raspberry Pi header to a breadboard, and it's a standard Raspberry Pi pinout, not a Pico pinout, which is a little bit confusing, but kind of matches up, but just kind of. So there's going to be a little bit of work to make that a bit easier. And then you see I've wired this to a analog output and analog input test little board that I bought. It's only like $4. It's just got a little speaker. So the analog output is a P pulse width modulation. So if we look at the code, and then we open it up. So I've also tinkered with the system fonts and things like that. It just makes it a bit nicer. There was issues with the other fonts. So here we initialize our Pi 2040, and then we just send it different frequencies. So I've done it very manually. Bonk. So I just turn things off when the mouse goes up. When the mouse goes down, I put in the frequency, and the duty cycle is on the side here. Right. So if we go back to our hardware screen, we can see if I run this and play it, you should hear horrible noises coming out of it, but they are piano noises. You can do a tune. Ooh, that was almost like a tune. So yeah, it's finding the Pico on its UART, which is here. So it's getting all the details, loads overlay, its version numbers, various things like that. So yeah, works very well. So I'm going to gradually go through for updating the CTI stuff for Radxa as well as just standard Picos, and hopefully that will lead to this being a platform. So I'm also buying the £40, $52 version of this to see if I can get it even cheaper. Yeah, the Radxa, it's a very, very cheap and very capable little platform. Just does its job nicely, is my review of it. I think it's brilliant.